Let's discuss question number 42 from test 1. And reading out the question, a 2 meter by 3 meter flat plate is suspended in a room and is subjected to airflow parallel to its surface along 3 meter long side. Okay, so you have a flat plate, okay, which is this is 3 meter, 2 meter. Well, dimensions don't go by the dimensions. Now, 3 meter may look smaller than 2 meter, but it's not scale. The figure is not scale. Subjected to airflow, which is parallel to 3 meters or something like this, and it's this thing is suspended in a room. So this question is basically from convection and or I mean you can say total drag force. So it's basically fluid mechanics. Or boundary layer type, not from convection. Okay, so area is given subjected to airflow. The airflow stream velocity is 7 meters per second. Temperature is 20 degrees Celsius. The total drag force acting is 0.86 Newton. Now remember, because it is suspended, so on the back side also you'll have airflow, right? Okay. Okay. So now basic idea is what is asked is the average coefficient CF is asked, and the density of air is given, which is 1.204 kg per meter cube. Okay, so now let's see what is average friction coefficient. Now let me first write down the definition of average friction coefficient, which is an important non-dimensional number in boundary layer, which basically measures how much the drag force is there. It's easy to find out this average friction coefficient for simple objects, but for complicated objects like an wing, which it is very difficult to find. Okay, so how it is defined? It is defined as the total force acting or the total drag force by the force due to your dynamic pressure. Now, what is dynamic pressure? So, area into your dynamic pressure is half rho v square. Now, look at why it is called dynamic pressure. If you recall your Bernoulli equation, this was basically Bernoulli equation constant. Now, if I just multiply rho throughout, I get something like this: P plus rho v square plus rho g h is equal to constant. So, this term is called your dynamic pressure. This is your absolute stagnant pressure. This is, I mean, the static pressure, what you measure in thermodynamic tables. This is that, and this is your dynamic pressure. Okay, and together they are called stagnant pressure because if you bring the flow to zero velocity, the P plus rho v square will be your the total pressure that is acting when there is no flow, and that is basically when the flow has become stagnant. So this is dynamic pressure, and this non-dimensional number which appears in boundary layer when you do a non-dimensional analysis for a boundary layer is what you get one of the non-dimensional number, and this is how it defined. So now what is area here? Area, it is both the side of the plate. So 2 into 3 is one side of the plate, into 2 will be the total area for both sides, which is 326 into 12 meter square. And now if I substitute everything here, I would get average friction coefficient. So force is 0.86 by area is 12, half density is 1.204, stream velocity is given, temperature is basically given to confuse you. So this value comes out to close to 0.00243 closely. I mean, you have to use a calculator to do it. So this is how we'll get the value. So this is just basically on the definition of average friction coefficient. Okay, so the answer is A. Option is A. Answer is 0.00243. Thank you.